Okay, so this question talks about filling a table of values in and then drawing a graph. So we're going to have to be fairly accurate in our plotting and so forth, but we need some values first. So the rule says to get the y value, I square the x value, take away twice the x value, and then take away 1. So when I've got x as -1, then it's literally saying I'm doing -1, always substitute in a bracket, so we're substituting the x value, it's being squared, take away 2 times -1, take away 1. So -1 squared is +1, and negative times a negative is a positive answer. Take away 2 times -1, well that's -2, but then we've got a minus sign in front of it, so take away negative becomes plus. So we've got 1 plus 2, and then we've got take away 1. So 1 plus 2 is 3, take away 1 is 2. We put 0 in here, so 0 take away 0 is 0, take away 1 is -1. And then we've got 3 to go in here, 3 squared is 9, take away 2 lots of 3 which was 6, so 9 take away 6 is 3, take away 1 more is 2. And then we've got 4 to go in here, 4 squared is 16, take away 8 is 8, and take away 1 is 7. What we should realise is, of course, that this is a quadratic graph because it's got power 2 as part of the right hand side here, and a quadratic graph we recognise should be a curved format and a U shape, or if it's a negative x squared, an N shape, but it has symmetry. So we've got to remember that this has symmetry, and if we look at the table we should see some symmetry going on. And what we can see here is 7, 7, 2, 2, -1, -1, and -2 for the minimum point. So, or it might be the minimum point, but it certainly goes down and then back up again. So we've got to look for those kind of patterns to make sure we haven't done any silly errors with our takeaways and involving negative numbers and so forth. Again, writing out what you're doing is useful to check. So then it says draw the graph, so that means plotting points. Well, what we need to remember is that these two create a coordinate. So -2, 7, and -1, 2, and so forth. So on the graph then, -2, 7, -1, 2, 0, -1, 1, -2, 2, -1, 3, 2, and 4, 7. And what we should do, of course, a graph has to be complete with the line or curve. It's a curve in this case, and we try and go through every cross with a smooth curve. So just got to be careful. We think about where every cross is, and we end up with that U shape, and then we go up. Okay, so we've got our curve and we've got the classic U shape that we're expecting for a quadratic, and we've got that symmetry going on. The question then develops into a solve using the graph. So it basically says solve that. Now that was the graph we drew, so that was the y equals x squared take away 2x take away 1, and it's asking us to say where does this curve equal x plus 3. So in other words, it's asking us to draw another line. So it's asking us to draw y equals x plus 3, and where those two things cross. So basically we've got our curve and we're going to have a straight line that's going to do that. That's the y equals x plus 3, and where these two cross we can come down and read off the x value. So that's the aim of what we're trying to do now. So if we want to draw x plus 3, then we've got lots of ways of doing it, but a quick way would be to choose 3 simple x values. Now the axes has got 0, 1 and 2 on it, so we might as well use 0, 1 and 2. And it says take the x value and add 3 to it. So add 3, add 3, add 3. So the coordinates will be 0, 3, 1, 4, and 2, 5, being careful to use the scale of the graph. So 2, 5. So once we've got our 3 points plotted, we know it's a straight line because it's linear. The x has only got power 1, and therefore we draw our line and we read off the values. So we come down, again being careful to read off accurately, so we come down and whoops, that's not where it was, that's where it crossed. So that one's not where it crossed, it's this one here, that's where the intersect points are. So if reading off the graph, then we can see that x either equals -1 or x equals 4. Those are the two solutions possible from where the intersect points were on the graphs. There was an alternative way to do this. Because it says solve, it didn't actually say you had to use the graph. So we could have said, well, this is a quadratic, so we know that if we solve quadratics by making them equal to 0, then we can usually factorise on an uncalculated paper. So we could have rearranged this to be, well, if we take x from that side, we'll end up with -3x. Then if we take away 3 from there, we'll end up with -4. And then we've made that side 0. And then because it's a quadratic, on an uncalculated paper, they should factorise fairly straightforward. So we've got x and x, and we can see that we want to make -4, so we know that one of these has got to be 4 and one of these has got to be 1. The only reason I know it's going to be 4 and 1 and not 2 and 2 is because I've got to get something that combines to give me 3. Because I need -3, then it's going to be -4 plus 1. So that's going to equal 0. And then when we've got brackets, if I put x as a 4 there, this will give me 0, which is what I wanted. So this bracket tells me that x is 4, and to make this bracket 0, because multiplying by 0 will give me 0 as the answer on the right hand side, then this tells me that x is going to be -1. So again, an alternative way of getting the answer to that, because it didn't say to specifically use the graph, although the solution by the graph method was fairly straightforward. But we got the same answers either way. The x value has to be -1 or x is 4. And of course we should check, we should put 4 in here and check that it gives us the same answer both sides and so forth. Okay, so that's solution using graphs, solution of equations, sorry, using graphs.